Hi, Michael. Hi, Vicente.
Boa
Hi,
noite.
Morri. Boa noite.
Hello, everyone.
Hello,
Hello, good morning.
Morri. Hello, Michael. Vicente, could you please give the basic information and welcome to Michael and Morri, please?
Okay, so good evening, everyone. My name is Vicente Scopacasa. I am the actual SCBeluz president, and I would like to give my welcome to Michael and also to Won-hee. I hope I said your name correctly.
Yeah, that's perfect. Thank you.
Okay. And in the name of SCBeluz, I would like to thank you both, for your time, your experience, your work, and in order to give us, the presentation. And of course, this is going to be very, very productive since we have a lot of people with real interest in the subject. So I would say most probably, Paulo, I think you can, you're going to be the mediator, right? As far as I understood from what we discussed. So please take it over.
Okay. Welcome, Michael. Welcome, Won-hee. Could you please, Won-hee and Michael, give to us a short description of your work, of your research, please?
Sure. Do you want to go first, Won-hee, or should I?
I mean, you can go first.
Okay. Good morning from Singapore. So if you are wondering why there's artificial lighting and it's quite dark in the background, it's just it's about 6 a.m. here, so sunrise hasn't quite hit yet this side of the world, but happy to be here. So thank you as well for the kind introductions. So my name is Michael Kent. I am a research fellow here at Symbabest, or our company is also known by Berkeley Education Alliance for Research in Singapore. So it's a non-profit company, a research center located here, obviously in Singapore, doing a lot of interdisciplinary research in building science and occupant satisfaction and sustainability. Specifically, we're focused in the tropics, but we do some peripheral research globally with other people in collaboration. For my research specifically focuses on obviously the daylighting aspects, focusing on both natural and electrical lighting, as well as how this is linked to also to visual perception. And a lot of my research at the beginning of my career, when I started as a PhD student and getting into an early stage career researcher, was on discomfort glare in buildings and visual comfort. But then it slowly transitions into looking at window view and window view design, research and application. And it's obviously led me to obviously partner with Won-hee and do a lot of different types of interesting research, which we will be presenting today to you.
Thank you.
Cool. So hello, everyone. I'm Won-hee Ko. I'm currently assistant professor at New Jersey Institute of Technology. I started that position early this January. I used to be a PhD student at UC Berkeley Center for the Built Environment. At the time, Michael and I kind of worked together for window view quality, and then that became for my dissertation for my PhD degree. And I'm also have background in facade design and environmental analysis and how we can understand what's the impact of the facades and window onto the occupants in terms of window view, daylight, or even thermal comfort and other aspects. So that's my primary goal. And then today we are going to focusing on the window view quality that we developed as a assessment framework, and then we also published a position statement last May two months ago. So we're going to present that piece, and then Michael also present his own research on like window view content as well. So I'm going to present first piece, and then Michael will take over, and then I will conclude with the position statement.
Thank you.
So should I share my screen and start the presentation, or should we wait for more folks? I wish Michael and I also are interested in like audience. Are they all like lighting designers, architects, or educators or researchers? Like what kind of disciplines they are in?
Well, Paulo, maybe you can answer that, because I'm not sure I recognize all those people's present here. So
Who are watching this presentation?
yeah, the people who is you know, which kind of work they do. I mean, architects,
Well,
researchers.
the most part of the people presented here that I know are architects. Several of them are students of graduate students of architecture in subject about the lighting, both daylighting as electrical lighting. And let me see the people I know. Here we have Maíra Vieira Dias is a doctor in lighting too. He teach lighting now, and who more? Rosie Hardy is a student of a graduate master degree candidate, very interested in lighting associated to health, human health. And Maite is a student of architecture too, in a graduate student. And the others, I don't. Jacqueline is a student of mine to developing research about LED.
Oh, okay.
Related to high buildings with a high penny rate. I don't know if it's saying a great high interior buildings illuminated by LED systems. And Renata is a student of mine too. She is studying human-centric lighting.
Right.
Okay, and the others I don't know if each of the presenters wish to present himself. Go ahead. Anybody wants to present?
Yeah, well, I believe we have a very good picture of the audience. So, Won-hee, if you please, I believe you can start your presentation, please.
Okay. Let me.
Thank you, Vicente.
Can you guys see my screen?
Yes.
Yes.
All right, great. So thank you everyone for attending our seminar on window view quality. So I'm gonna start this conversation with a little bit of high level of big picture. So window view has been one of the primary design elements in architecture. And having a proper window indoors became more important during COVID time, as it is primarily mean for the visual connection to outdoors, such as visual stimulus, circadian stimulus, or connection to other humans. So there are quite a lot of like scientific literature demonstrated that positive effect of window view on occupants, including improved health and well-being, cognitive performance and stress recovery, and environmental satisfaction and reduced comfort. A good window view may also increase the economic value of the buildings. However, even though many benefits from the window view have been recognized, like I summarized before, this research is often conducted using images rather than the real window, or in field study setting where lighting condition is not controlled. So our research team at UC Berkeley at CBE conducted a lab study that evaluated the impact of having a window view in workplace. So while assessing the effect of the windows, we considered the concept of multi-sensory system, as you can see in the image on your left. So human perceive the environment through multiple sensory system, not only like visual system. There's a lot of different aspects, but we know that like there's a vision is most dominant sensory system among these 5 sensory systems. So we hypothesized that having a window view versus no view would affect the occupant thermal response differently. And then we conducted a human subject study in climated chamber where the system can control the lighting, thermal, and ventilation conditions. So by using floor to ceiling curtain, as you can see on the picture, we created 2 different conditions, one without the windows and one with the windows, while keeping the thermal identical spaces with the 28 Celsius slightly warm condition. So the window has 3 views, as you can see in the figure. And then we recruited 86 people and exposed them to different conditions like with window and versus no window. And then keeping thermally identical spaces. And the participants stayed each rooms for about an hour while taking surveys on thermal perception, emotions, and cognitive performance tests. So when we look at the result, we found that with the windows, people felt cooler and felt happier and more focused when they are in the window view room, even though we kept all the environmental stimuli identical because it was in the climated chamber at UC Berkeley CBE. So considering these multiple effects of the window access, we see that there's a providing a window view in workplace is important for comfort, well-being, productivity of occupants. So when I kind of wanted to point out the important findings here is like, even though there's some thermally identical rooms, people felt cooler if there's a window present. So we kind of tried to understand how much they felt cooler. So it's about 100 Celsius degree difference. And then that means that 12% more people thermally comfortable. And then when we simulate the building in California, San Francisco, that 1 degree Celsius difference in the thermal comfort setting, it's gonna have like 8% in cooling energy reduction, as well as 6.5% of total HVAC energy reduction. So it's really quite sensational like result for us, because only having window versus no view actually like make the people feel more thermally comfortable and cooler, and then they can have some energy saving implication. And also there's a psychological aspect, like, you know, like emotions, and also like better work performance and concentration. So it was interesting finding, but then what we like thought about this research was like, it was a tree view. And then we were like asking about ourselves that, do we have enough guidelines or standard we can follow as a designer or architect or lighting designers can create the good window view space? But the short answer was no. So we were kind of questioning like, what could be the major variable that determine quality of the window view. And then if I ask a question, where would you prefer to work, by imagine one of these pictures, your window view, you may want to choose like the view on your right, right? It's so obvious because the other two views are really like bad. And then when we ask people like why you think that it's bad, there's multiple different reasons. The view on your right has like really nice view to the tree, like skies, and the color is nice. But it's not only about the content. It's also like really big window compared to the other two window view. And also it's not blocked by any like shading system or like mullions or window frames. It's really clear. So all these factors kind of contribute to the overall view quality, but we found that there's no framework or design guidelines kind of like merge everything into a single piece. So we wanted to kind of dig up more. So Michael and I and other co-authors in the paper worked on some literature review process. So here are some like methodological, like a summary of it. So we reviewed multiple different sources. So there are some building standards like SIPC or European guideline, ASHRAE, and ISS American guidelines. And there are some international green certification systems, LEED, WELL, BREEAM, or Green Globe, or Green Star, and other aspects. And also we like search for all the literature about the window view in different domain, because window view quality has been studied majorly in architecture, but there are some other really valuable resources we can find in urban planning, landscape, or environmental psychology, or even vision science. So we kind of review all those literature, and then we kind of like categorize all the criteria we found, and then we were able to develop some organic framework that can determine or assess or can be used for window view quality assessment. So there are 3 variables we are going to talk about in the next few slides. And then after the framework development, we invited all the industry practitioners in the States. And it was about more 150 people. And then we kind of discuss about how we can utilize this framework more to support the design process of the building and make it work rather than sitting at the table or like a paper. And then we kind of suggested that we can actually develop some mathematical format and then design matrix, which called View Quality Index, which is VQI. So first, I'm going to talk about the 3 different variables that determine window view quality. So if you imagine that this box is a building, the first variable that determines window view quality is view content. It's about what you see through the window. And then if all of you guys have like architecture background, as you guys know that the building orientation and building massing and even site planning is important for that. And then the second variable is view access. It's about how much window view you have in particular space. And then it's directly related to design of the facades, like a building envelope and window, and also the floor layer. So if you're sitting far from the window, even though window view is big, you may have not enough window access. And then the third variable was view clarity. It's about how clearly you can see through the window, and it's directly related to facade materials and how we control it. So all these 3 variables matters, and then based on those 3 variables, we can have overall view quality. So in following slides, I'm going to be going a little bit in deeper in each variable and what's the design criteria we found in the literature. So first variable was about the content, about the sum of the visual features seen in the window view. So there are 4 main criteria we found: nature versus urban features, horizontal stratification, which is like what kind of layers you can see in the picture, and then content distance, how far the object appear in your view, and then also dynamic features, if there's any movement. So if we find some like examples, like what could consider to be good versus not good view, like nature is usually preferred over the people compared to the urban features. And also horizontal stratification is, like I said, it's different layers. Like it's if there's a ground, if there's like a building and landscape, and also there's a sky, if we have all 3 layers together, it could consider to be a very good view. And there's a content distance, which Michael will talk about more. In general, like far distant view is preferred over the nearby view. And then in terms of the movement, if there's any type of movement like a people, water features, even traffic flow, you can see in the picture, if there's any like dynamic features, people like it more than like static view. And then the second variable is view access, which is about metrics quantifying how much of the window view an occupant can see from a particular location within a space. So the criteria we found in literature is the view angle of the view window, and also distance from the window or window to wall ratio, which is kind of common metrics in architecture. And also we found spatial assessment of the view access. So if I describe it a little further, view angle is the angle from the occupants viewing the position to the vertical or horizontal window frame. And European and LEED use the view angle to evaluate the view access. And then distance from the window and then the window to wall ratio are BREEAM, LEED, and WELL uses that metrics to evaluate the view access. And in green certification systems, the view access requirements most rely on if the occupied space has visual contact with the windows. However, the definition or requirement of the visual contact is missing. In simulations, some researchers used ray casts from the viewpoint, as you can see in the bottom right image. However, there are so many different metrics, but however, there is no metrics that can consider all these factors together. And often these are not based on human subject studies. Rather, like it's based on the rule of thumb. And then the third variable is view clarity. Is a metrics about how clearly we can see through the glazing layer. So it accounts for visual obstruction present at the window before, after, and inside of the glazing layers. But it is most understudied area compared to like other two variables. But it's related to facade material, which is increasingly have a lot of like variation in terms of the application. So there are like few aspects under view clarity. So first, window design, especially the placing of the glazing support like mullions can obstruct the view. As you can see in the image on your top left, there's like, there's mullions can block the views abruptly if it layered with the specific views. And also glazing and shading material can also block, distort the window view as shown in the image. Even if we design the building with the maximum glass area, like you see in the photos in the building Vancouver, often people need to draw all the blinds down, like shading piece down because of the glare. So balance between visual thermal discomfort or privacy even and window view should be considered. Also, different shade material can yield different view clarity. As you can see in the photo on the bottom right, there's like some difference between two different shades. One is like a beige color and the other one is black. And then even though these two has exactly same solar transmittance values, the effect on our view clarity is quite different. So at CBE currently, the research team there and then I myself is working on this aspect because it's really important aspect to consider in the future design on the building and selection of the facade material. And then the last point under the view clarity is about the temporal and composition attributes, such as what's minimum acceptable level of view clarity considering partial operation of the shade and how long window can be viewed under the level. Those could be studied further. And these temporal attributes also need to be considered in conjunction with the climate-based daylight metrics, because we do have some metrics consider the shading piece elements. And then we believe that view clarity is not separate from the daylight effect. So it's really important to consider both together. So far, I explained three variables of the window view quality and the framework. And now I'm introducing an index that describes the conceptual basis of the view quality, which is VQI. It has basic equation format that all three variables, content, access, and clarity plays a role for the view quality. So it has also like product relationship, as you can see in the first few lines. So the basic concept was based on like, if one of the variable is low, even if the other two are high, the resulted view quality will be still low. So to reflect this, we proposed this equation as a product relationship of these three variables. So we put these three images to show that relationship and then the equation further. So for the first image, if the view content is low quality, example like nearby brick wall, the occupant would not be satisfied even with high level of view access, which is like really big window, and high clarity, which is clear glass. By the same token, if an occupant sits far away from the window, for example, when you see in the image in the middle, even though the window view itself is really nice, and then even if it's a clear, it's not gonna be like a high view quality. Similarly, if the view deck consistently requires a shading device to protect the occupant from glare achieves little view clarity, therefore insufficient view quality, as you can see in the last photo. So this figure shows some examples how VQI can be calculated across different window views. So using 4 labels: insufficient, sufficient, and good and excellent, following European guidelines. As the green bar shows, VQI ranges 0 lowest to 1 highest. So you can see that if one of the variables is below minimum, we put as a 0, and then since its equation is product, so it's gonna be 0, which is insufficient. So the overall quality of the view are rated like insufficient, as I say. So if the view has all 3 layers and nature with the good access and clarity, it will achieve the excellence you can see on the left. So here is some summary of the contribution of this framework. First, framework provide the concept design recommendations and also introduced VQI model, and it was accessed by over 150 architects and practitioners already, and it was published in a peer-reviewed journal article. And with that framework, we can provide a quality views in building design, and then that quality view will improve comfort, well-being, and health. And also this could increase the productivity of the office workers. And in research standpoint of view, it was first holistic design framework and solved the large gaps and built upon a comprehensive literature review. So from now on, Michael will take over the presentation, and then he will introduce more about the view content research he published. So I'm gonna stop share now.
Perfect. Okay, I'll just.
Thank you very much, Won-hee. I have a question. Do you think the difference in climate zones can influence the view quality index or not?
I think it is, because the third variable, which is view clarity, is directly related to the daylighting, because so it's not like separate from the like lighting environment and then view itself. So it's combined. So climate zone will determine what kind of daylighting condition it's going to be outside, and it's going to impact on clarity. So that's why it's really important for the lighting and daylighting researchers to consider window view quality in their research, and also design process as well. Yeah. And so we are, Michael and I try to push, like any daylighting guidelines or certification system, when they talk about the daylighting, we also need to talk about the window view quality.
Yeah. Anybody have any questions to Won-hee?
Or we can get a question after Michael.
Okay.
Yeah.
Okay, I will prefer. Michael, please.
By the way, can you see my screen?
Yeah.
Okay, awesome. Right. Okay, so I'm gonna move on with this. Okay, let's see if it's working. Okay, so So what content do occupants need to see in the view? So in Wenhei's presentation, she kind of went over this at a higher level in terms of describing this as view content. But in my presentation, what I'm going to do is give an overview of some of the more important features occupants need to see, focusing on the specific aspects that generally leverage, high design quality in practice. So generally what we see in standards is that there are two criteria that generally emerge for content, which have already been mentioned, which generally convey different kind of types of quality when they're seen by the occupant. So one criterion is something called horizontal stratification, which is basically used to separate the structural content of any given view into 3 unique layers by boundaries that run across their horizontal axis. And this permits any view to really be divided into a maximum of 3 layers, so the ground, the landscape, and the sky. And while any view can be, in theory, separated into a maximum of 3 potential layers, you probably would imagine that not every view will always contain each of these layers. So for example, if we look at, for example, a view of an ocean's horizon, this will generally only contain the ground and sky layers. Whereas if we look at, for example, a skylight on the roof, obviously this will only contain the sky layer and not the landscape or ground. Second criterion, which is also described, is distance, and measures the proximity of outdoor content relative to the window. And generally, as Wenhei already described, content that is distant from the window is generally seen as being more beneficial than nearby content, since this allows occupants to see more diverse visual information, but also provides them with opportunities for visual relief, particularly after prolonged periods where, for example, we spend inside the building looking at objects that are quite close by. So for example, computer screens. And this on the long run can lead to kind of like ocular strain, like symptoms of myopia. And distant views are generally seen as a way of kind of counteracting those negative kind of health effects on our eyes. Distant views also offer better privacy. So they actually do help prevent people from the outside of the building from looking in through the window as well. So in the Society of Light and Lighting Guide 10 in the UK, and also the European norm Daylight in Buildings, both these content criteria are actually tabulated into design thresholds, which can be used to describe different levels of view quality. So in the Society of Light and Lighting LG 10, these criteria range from insufficient on the low end all the way up to excellent, which describe excellent views, high-end excellent views, where the inclusion of more layers in the view and further content distance can be used to kind of describe higher view quality. So therefore, to achieve an excellent view, a designer must try to aim to design for a view that has a ground, landscape, and sky layer, as well as have view content that is equal or greater than 50 meters from the window. On a related note, these recommendations in the European standard for daylight in buildings have some subtle differences, but generally, if you compare them, the information is relatively the same. So the first three that I'm going to describe kind of looked at the criterion for content distance, specifically whether this criterion indeed promotes higher levels of visual satisfaction, particularly when content is seen further away from the window. And in parallel to this aim, what we also wanted to know was whether this effect is influenced by the content that's seen. So if this effect of content distance is universally applicable for any given view, or it actually depends on what can be seen within the view itself. So when we began this research endeavor, a challenge that we faced was actually how do we measure content distance in practice? Since there wasn't really much guidelines given. So to kind of get around these problems, we actually came up with our own method, because in practice, when you look at most views, they actually have a lot of complex visual information. And often this information is actually separated. So for example, if you look at different multiple high-rise buildings, they're not really one continuous structure and actually located as well at varying distances from the window. So this actually raises important questions in terms of which one do we actually measure, and how is this measurement representative of the overall distance from the window? So we devised a method to kind of overcome these problems by using photographic images from different window views, and then came up with this three-stage design process that can be applied. So in the first stage, the landscape layer is identified. So generally, when we think about content distance, this content is generally a reference to things that are located between the ground and sky layer. So it concerns the landscape layer. And to identify this kind of landscape layer in the view, what we did was use the instructions from the Lighting Guide 10, which describes two junction points located where adjacent layers meet within the view. And this method, I won't go into it word by word, but it's actually quite useful because it helps avoid problems when, for example, some layers are not available or some small features can be seen in the view, and you don't want to include those within the calculation method because it's going to unfairly influence the estimate of distance. So for example, like a small car or a small bush, those things want to be ignored, and we really want to identify, elements we think are the most important that need to be included within this calculation. The next method was to look at the visual field angle. So we set the camera focal length to 60 degrees as a horizontal visual angle, which actually corresponds nicely to the immediate human visual field. So it's not the entire visual field, but it's actually focusing, if you look at the visual angles in more granularity, it's actually separated into three different kind of layers. And we're just looking at kind of the middle layer. And when we apply this onto a plan view of the site, which can be taken from, for example, Google Maps or online, for example, an online maps or site plan, anything that shows the site in any great particular detail, this actually allows landscape elements to be easily identified from the assumed occupant viewing position, which in this case, you can assume that they're sitting next to the window, looking out at the view. So lastly, in the third stage, we calculated the landscape distance. So the method that we chose to apply utilizes two different values. So which are the parts of the landscape layer which are either closest or furthest away from the window. So in other words, the minimum and maximum distances. The landscape distance is then taken as the median value of these two extreme measurements. And this actually helps overcome issues when, for example, these two different measurement points are considerably different from each other, which means, for example, if this is the case and an architect or a designer selects one or the other, but not both, this can probably lead to very different interpretations for what the content distance actually is. So for example, like if the designer specifies the minimum distance, this could translate to an insufficient view, whereas if they select only the maximum distance from the window, this could conversely translate to an excellent view, which obviously causes some problems in practice. So to quantify view perception, this was measured by the satisfaction or dissatisfaction given to three different parameters. So namely connection to the outside, visual content, and visual privacy. And collectively, we kind of assumed that this would give a complete picture or a complete kind of idea of what people are seeing in the view and how they appraised that information. So connection to the outside was used to describe the provision for dynamic information seen in the view in terms of, for example, like temporal changes that could occur, such as the time of day, weather, people, for example, that may occur on a regular basis. And often this parameter connection to the outside is actually often seen as being one of the most important things people actually need in a view that kind of decides their preferences towards it. The second parameter is visual content, which describes directly what can actually be seen in the view itself. And this could be, for example, nature or buildings. And the last parameter is visual privacy, which kind of describes the feeling or perception of people from the outside being able to look in, which obviously creates a sensation of discomfort if this happens on a regular basis. As you might imagine, it's actually, it's not particularly straightforward how connection to the outside or visual privacy for pictures or static content can be evaluated. So what we did was we asked participants to kind of imagine that these views contain certain visual cues. So for example, like a nearby pavement or a nearby road. And these cues are representative of either good or poor connection to the outside or visual privacy. So 3 surveys were designed to evaluate either connection to the outside, visual content, or visual privacy. And each survey had the same images, but we asked different people to provide different responses to each survey. So in each survey, 6 different window view images were included, and these formed 3 comparative pairs that tested the influence of landscape distance. So for each pair, you will see that certain content were matched as close as possible, providing, for example, a similar number of layers, urban and nature features, as well as, for example, you can see like one has low-rise buildings, whereas another pair has high-rise buildings. But the key difference between each of these pairs was that one view had a nearby landscape, so it's the top row, whereas the other kind of image, its counterpart image, had distant landscape, so it's the bottom row. Okay, so if we return back to the original question, does landscape distance affect visual satisfaction? Well, the results that we found was that our work consistently showed that as the landscape distance increased and the content that was seen in the window was further away, there are actually higher levels of visual satisfaction given to each of the 3 parameters that were measured. And these effects of increased distance are actually relatively large and actually present across each of the 3 different comparisons that were drawn, which indicates that, for example, this effect is quite prevalent across different types of view content, ranging from, for example, low-rise buildings to high-rise buildings, and as well as views that contain a different number of horizontal layers. So ultimately, what we learn from this is that if we actually do design views to advocate and support distant view content, this will likely promote higher occupant satisfaction in buildings when they're actually living, working inside those places. So to determine whether view content affects landscape, the landscape distance effect, 2 reference views were used. One was completely covered by nature, whereas the other was fully urban, so you can see them on the left. And what we did was we compared the visual satisfaction given to these 2 reference views to 6 other views. And each of these 6 other views had greater landscape distances. And what we anticipated from these comparisons was that the difference in visual satisfaction between the nature reference view and the 6 other window views that were compared would actually be much smaller than the differences that we calculated for the urban view with the same 6 window view images. And what this would suggest is that, for example, because nature is more pleasant, generally speaking, that this would suppress the effects of landscape distance. So to test this, what we did was we designed an experiment using an artificial window, and we backlit a lot of these window view images onto that artificial window, giving the appearance that this is actually a relatively similar or visual appearance to an actual window itself. And data from this experiment, as well as the survey that we're using for, were directly compared to see if we can actually replicate the same results from 2 different types of experimental settings. Okay, so does visual content also matter when considering content distance? Well, generally, yeah, the answer is yes. So the visual content does matter. So if the view contains a lot of nearby nature, the effect of increased content distance is actually much smaller. Actually, what we also found was actually there was no significant increase at all that we could detect. Whereas, for example, if we have, for example, nearby urban features, for example, in view, such as this nearby air conditioning units, this effect of increased content distance is significantly larger, as indicated by the percentage changes that are illustrated in the two boxes. And this really raises seminal questions to whether this distance criterion can be universally kind of applied to any given window view, regardless of its content. Okay, so besides horizontal stratification and content distance, the lighting guides also provide recommendations used to evaluate 5 other environmental information criteria. However, based on our review of the scientific literature, we actually couldn't find any studies that actually evaluated their practical viability. So these criteria, when laid out in a tabular format, actually describe 5 different aspects of the window view, namely location, time, weather, nature, and people. And the inclusion or absence of any of these actually kind of describe the level of view quality according to the same 4 design thresholds indicated before, which range from insufficient all the way up to excellent. And generally, one interesting aspect about this table is that each criterion doesn't actually have an equal weighted importance across the 4 different design thresholds. So according to these criteria, time and weather actually are used to support all 4 levels of quality, so have a higher importance, while nature and people have a much smaller role, supporting only the high-end views that are classified as either good or excellent. So the aim of our work was relatively straightforward, which was actually to evaluate the practical utility for these 5 different environmental criteria. So in other words, if we provide subjective evaluations to each of these kind of 5 different criteria, can they be used to predict differences in window view preferences? So the study was divided into 2 different stages. So in stage 1, we independently examined view preferences by grouping 6 different window views into 3 different pairs. And these views were previously used in the content distance study. And what we did was create a side-by-side comparative procedure, which was implemented via an online survey to determine the differences in preference across each of these pairs. Survey respondents were asked to indicate which view they preferred or did not prefer. And in each view, to avoid kind of forcing a response of preference when there wasn't none, neither no difference or no preference criterion was also included. So as expected, views with nature and kind of distant content were generally preferred over views with urban and nearby content, so similar as the results before. And these preferences were higher for the view containing only nature in pair 1 and a distant landscape in pair 3. And besides these findings, what we actually did find quite interesting was that there was actually no noticeable difference in preference between the nearby nature view and the distant nature view in pair 2. With actually some people even preferring nearby nature or actually having no preference for either of these views. So this actually is quite congruent with, supportive with the notion that nearby nature actually does suppress the effects of content distance. And when we return back to our original aim, we actually believe that the 5 environmental criteria wouldn't be able to accurately predict the differences in preference for pair 2. But since these preferences obviously favor significantly the views in pair 1 and pair 3, we believe that the prediction accuracy would have been higher for these pairs. So in the second stage, the 3 pairs were organized into 2 different surveys, which were distributed globally. And each survey contained the same questions, but the survey respondents evaluated different views. And in the surveys, the 5 questions appeared, and we asked respondents to subjectively evaluate each of the different criteria. And to aid in their understanding of the questions, some criteria were framed around some additional content. So for example, if you take the criterion for people, we asked them if it was possible to see movement from different visual cues. So for example, from a nearby road or different walking paths. Whilst for nature, the question was slightly altered to how connected to nature they felt. And the latter alteration overcame problems encountered when we tried to generate granular kind of measurements for this criterion. So for example, in other words, views would either contain or would be absent of nature, yet this binary evaluation actually doesn't give any indication for how much nature there actually is present within the view. And this can cause a lot of problems, for example, because one view can have like a view over a large forest, whereas another one could just have like a potted plant, right in front of the window, and both would essentially meet the assumption, meet the criterion for nature. But obviously, this causes this probably is not reasonable in practice to implement it in such a manner. So the questions were assessed using a 5-point scale ranging from not at all to completely. And this data was then used, obviously, to analyze the views later on. So data from both surveys, Survey 1 and Survey 2, were then combined, creating one single and large data set. And what we did was we overlaid 3 different machine learning algorithms onto this data set, which were random forest, decision tree, and neural networks. Essentially, these algorithms have quite a simple aim, which is basically just to maximize the level of prediction accuracy. Since we don't know which one would provide the highest level, obviously we use multiple ones and just compare them against each other. And how this works is that we use the subjective surveyed assessments given to the 5 different environmental criteria, and these served as predictor variables. And these were used to determine how well they could predict the differences in each of the different window view pairs, which acted as the outcome variable. So in other words, depending on how people evaluated these environmental criteria, the algorithm would inherently know which view that was without actually being provided any additional information, so actually what the view looked like. To implement these algorithms, the dataset was split into 2 parts, so 70% being allocated to a training dataset, and the remaining 30% acted or served as the test dataset. And essentially what these algorithms were doing was to search for trends and patterns within the training dataset. And once the algorithm was trained, applied what it had learned onto the unseen portion of the dataset, which was the testing dataset part. So the table on the left shows the prediction accuracy percentages when the trained algorithm was applied to the test dataset. So in short, if the accuracy was 100%, the algorithm would correctly predict the window view based on the environmental criteria every time. So it's perfect. It's a perfect representation of accuracy. However, in reality, such high levels kind of rarely occur. So obviously, we need to compare these in a little bit more detail. So what this table shows is that for pair 1 and 3, accuracy is relatively high, whereas for pair 2, the prediction accuracy was relatively low. Because the differences in preference across pairs 1 and 3 were much larger in stage 1, this can be used to kind of explain why the accuracies were higher in stage 2. And similar assertions can also be made for pair 2 because the difference in preference between those 2 views was indistinguishable. So it also kind of makes sense that there will be a lower prediction accuracy when these 2 views are compared against each other. So to kind of show what's happening in a little bit more detail beyond those percentage kind of values, I've illustrated here on the right a decision tree. Because this decision tree is generally seen as the most simplest kind of algorithm out of the 3, but also performed kind of equally well compared to random forest and neural networks. It's actually quite a candid kind of algorithm to use to kind of show what's happening under the hood. So essentially what you can see here for the tree is the decision rules that are made when classifying the two different views in pair 3 based on the survey assessments that were given to the environmental criteria. So for this pair of views, nature or connection to nature was deemed the most important decision rule to use to classify the two different views, followed by location. And in this instance, when nature was higher, was evaluated higher, so for example, greater than moderately on the scale, there's a higher probability that this view would contain distant content with a lot of greenery that's seen on the ground layer. Conversely, when the assessments and also location for both nature and location, were less than moderately, there's a higher probability that this view would contain nearby content, which generally makes sense because if we look at the image, the resultant image actually shows less greenery, and also there's less visual cues that could be used to determine, where the occupant's located. Okay, so in my final slides, I just wanted to articulate 3 takeaway messages. So firstly, designing for distant content in window views will generally convey positive effects as intended by existing daylighting standards. And our work, however, provides what we also provide on top is a a more rigorous approach to help designers measure this criterion with more accuracy, which helps overcome areas that we perceived to occur in practice when measuring complex content seen in the view, such as, for example, multiple measurement points from different buildings that are also contained in the same view. Secondly, we found that the 5 environmental criteria generally provided high prediction accuracy when classifying different window view preferences. So while these design criteria were previously untested, our research began to show that they do have practical utility. And if they are implemented in practice, these two would also help support view content seen by the occupant and obviously view quality as well. And finally, both studies, what we generally found in both studies was that the role of nature or having greenery such as trees, bushes, and those types of things could also include, for example, biophilic design. These actually have a higher weighted importance across both studies. So what we found obviously in the content distance study was that nature actually could suppress this effect, while, for example, for the 5 environmental criteria, nature was generally seen as the most influential criterion that predicted window view preferences. And collectively, it could probably have a higher weighted importance than the other 4. So if you design just for nature, you're more likely to create a high quality view, whereas if you try to design for these 5 different elements individually and cumulatively add them together. Currently, however, the role of nature as a design criterion is actually only used to support high-end views, so good or excellent thresholds, and not lower thresholds denoting a sufficient view. So in light of these results, what we're proposing in the new design recommendations is that nature is actually given a more prominent role within window view design. Okay, so with that, I will return it back to Wan-Hee just to present the final slides.
Okay, thank you, Michael. I have a question to you, Michael, and to you, Wan-Hee. In these experiments, in these cells, the ambient was completely white. All right. Do you think the use of color in the cells, the interior, and even with color that mimics the nature can change the perception of the users? Do you have an experiment using colors in these cells or not yet?
You mean like individually testing like different primary and secondary colors, or just as a general if you saturate with high hue, brightness, do you mean along those lines, or is it just black and white versus color, as in like a study?
The colors of the walls, as example.
Oh, okay.
If you paint the walls with green, as example,
yeah,
when you are seeing a natural landscape, the interior to bring indoor the colors of the outside. Do you think or do you have an experiment that this can change the perception of the observer?
Yeah, okay, I see what you mean now. I mean, we haven't done it personally. I don't know if there is any study available. I mean, one you can also kind of pitch in afterwards as well, if there is. But I would assume that if you did change the colors, it would have an influence on the view perception, because obviously the color of the walls, the adjacent walls surrounding the window view frame, and whatever's seen in the window view would have a contrasting effect. So it would change, for example, how they perceive the two colors when they're kind of right next to each other. But this effect would probably be a bit difficult to kind of evaluate in practice, because I think when you change the colors as well, it introduces other problems, such as, for example, glare, because the contrast between the window is always going to be brighter than the surrounding walls. And if you, for example, have a darker color walls against a window, what this generally does is create a more contrast and it will cause more discomfort. Whether or not that would influence the view, not quite sure, but generally what we find with that is that if you have a better window view, generally you can tolerate more glare, which has generally been found. So the effect could be there, but I don't know of any studies at the moment that have systematically tested it. But I would assume, just making some assertions based on what we do know about color perception, color rendition, color temperatures, that there would be some sort of effect.
So also for me, I haven't seen any literature specifically tested the effect of the wall color on view perception, but I did read some papers just talking about the wall color in general, not with the view. So if there's some color of the wall is more pastel, pink and things, it's kind of calming, and it's more directly related to emotional responses of the human. So I read some papers about the interior design practice, how they choose the color, and then when they want to create the some focus environment, they try to minimize the color in the wall so that it's less stimulus and it can be more focused for the work that they need to do in the space. Those kind of studies, but not directly related to the window view perception with the wall. Or the other example may be not green color, but it could be just bringing green wall to the wall, right? It's a biophilia and biophilic aspect. If you can bring the view similar to the view to the indoor environment, that's more bringing actual natural element to the building, like a wood surface or leaves and things, or water features on the wall and things. Those are the things that I saw, but not specifically how the wall color and view perception can be correlated, or if they have any trade-off or synergic effect. No, that could be interesting to consider. But in general, people don't like to have really strong saturated color in the spaces for many different reasons. So that's probably the reason why there are not many studies being done other than playground or kids spaces, because they need a lot of stimulus. Oh, yeah. Oh, you're muted.
Yeah, I agree that not saturated color, but if we have light colors inside and colors that is similar to outside colors, maybe this is a point, an interesting point to next researches. Don't you agree?
Yeah, I think it would be interesting to see if the color of the wall is correlated with the view that the space has, and then if we compare that with something really contrasts, if the perception of the view may change. I think that would be really interesting aspect to consider.
Okay. Thank
But
you very
then,
much.
to study that one, I think, of course, we can paint the space, but maybe it's easier to do VR study, virtual reality. I mean, of course, there's like some pros and cons, like if you want to use VR or not, or real. But in real space, you can only paint once, and you cannot really change quickly. So I'm just thought of that.
Okay, thank you. Now,
So we have a couple more slides about the position
okay.
statement, but
Yeah.
if the time is okay.
Yeah, we have
No,
time.
it's okay. It's okay.
It's
Go
okay.
ahead,
It's
please.
okay.
Okay, so
Okay.
you guys see my screen, right? The blue screen.
Yes.
Okay.
Okay, I'm not sure. I think I need to unshare because I don't have the. Okay, so somehow I don't have the control over the next slide. Let me just try this. I think my screen is kind of stuck. Let me just pull it out again. Sorry about that. Because it's been a while.
In your time, don't travel.
Yeah. Okay. So we just wanted to end our presentation with the sharing of like the position statement we developed. So we organized a virtual symposium and in-person workshop about the window view quality last year. And then we had this lineup that we kind of like introduced like what other researchers was working on in terms of the window view. So there's like 3 different sections, and Michael and I was invited as a speaker too. So there's like 3 different sessions. First one was a view research and more like a scientific research. And then the second session was more about how we developed the view index. And then the third one was about how the practitioners utilize assessment method for the window view quality. So if you guys are interested in any of these topics, you guys can kind of take a look, because we have like a videos recorded, and each of them are 15-minute. And then we organize the in-person workshop and then to discuss the definition of the window view quality, and then reach some consensus on what should be done for the next steps, and identified research gaps. And we ask people around to sign off position statement if they agree. So the outcome of that workshop and virtual symposium was published as a guest editorial in Lucas, which is journal in lighting field in the States. So first thing was about the definition. So when we want to talk about window view quality, we really cannot find what can be the exact definition. So as a group, we kind of discussed what should be done, and then we kind of like agreed upon the definition of the window view quality as the quality of the visual connection to the outdoors that satisfies building occupants. And of course, we discussed a lot, and I also, Paulo, you mentioned about the conceptual factors. So there's a physical attributes like climate, latitude, surrounding landscape, or built environment can influence the window view quality or definition of the window view quality, because each different people or each different climate may have different quality that satisfies occupants. And also social related factors like demographics or cultural aspect may have different influences. For example, in one of the example we discussed in the workshop was like there's a Middle Eastern countries, they may consider the privacy is the top priority, and then maybe the quality that we are kind of like developing as a criteria may not work for them. So how we solve the problem, it's more like a design team that they already, if we as a researcher, we create a tool and then guidelines, and which could be flexibly like work together. Design team can set up the each design architectural goal, and then if the building program type or other aspect is really important to consider, they can kind of utilize or adopt the guideline to support the design process. And then we kind of talked about like 3 different variables and what should be done. And then there's a 3 aspect we should research further in terms of content, which is one of them is the nature views. I think Paolo, you kind of asked about the wall, and then like we talked a lot about like various form of the nature, like green wall and green facades or greenery within the space. If it's gonna be similar effect as like a nice green view outdoor, it's not studied really like thoroughly. So it could be one aspect to be considered for the students or researchers for future study. And then the other one is human man-made views. So there are a lot of emphasis on nature is good and urban setting is not so great. But we found that there's artifacts, as you can see the pictures in the middle, like there's a really nice architecturally well-organized like sculpture can actually create pretty good positive effect to the occupants, even though it's not nature. And then those are the things that like we have really don't have much understanding, so it can be researched further. And then the last part in the content is like movement in the views. So we know that like it's like scale, if it's big movement or small movement, and how frequently it's moving and how periodically like moving. That's all like relevant question to answer. It's because, for example, in classrooms, if there's a really big things are moving right next to the window, then kids will not focus on what the teacher is instructing. So those are the relevant like topics that should research further. And then for the access, as I briefly mentioned before, there are a lot of different metrics here and there, but there's no combined or merged integrated method to quantify amount of the view available to occupant. And then the other point is also like we need a spatial evaluation of the view access. We can maybe evaluate the one specific point within the space, like that access quality based on what we have currently, but we need to have better like metrics we can spatially like analyze the view access. And then the other aspect is like even if you want to include some window view quality assessment in the design stage, we may not have all the information available in all the stage of building design. So we may need to kind of propose probability of the view access achieved without having, all the like furniture layout or facade design to have better understanding of, to include those in window view access effect. And then lastly, the clarity wise, there's a lot more study should be done in terms of how optical properties and patterns of the facade material influence view clarity, and how the facade operation, like, if the dynamic part of the glass or like a blinds or shade, it's all dynamic component, which is combined with the glare and overheating and privacy issues, and how we can operate more like optimize in terms of the view and daylight and other aspect is important. And then the other aspect is like also like there are a lot of reflections. If it's like, the contrast between the indoor and outdoor is quite different. There are maintenance issues and other aspects to be considered in terms of clarity research. And then the very last point that we discussed in the group and the symposium and in-person workshop was how we can integrate all those like 3 different variables into like design process. And then one thing that we all agreed is like our assessment tool or guidelines should have enough flexibility for design team to adapt variables that meet design requirement. And then it should allow balance among the 3 different variables. And then we do need a lot more empirical research, meaning we should have more research with the human subject to understand better about the human perception. And then for that, we need to use a lot different research method. It could be lab or field study in a real space, or 2D or 3D images, or virtual reality environment, that method that I just mentioned, to answer like Paulo's like question. And also when we do that experiment with the human subject, we should be able to observe the satisfaction response curve and try to understand what could be design threshold we can propose based on that result. So that will be like end goal, to integrate window view quality as a one of the component in performance space of like design workflow, which lighting, like thermal and air quality is already pretty much set up, and people are doing it to address the early design decisions, but window view quality is not there yet. So we found that there's a lot to be done. And then we hope that our presentation is kind of, you know, give you guys some overview of like what should be done. And then these are the articles that we presented in this presentation. So you guys can click the link to take a look much further. So Michael and I would thank everyone for listening to our presentation today, and also thank you, Paolo, to invite us this event. And we can answer any questions if you guys have any further.
Okay, so name of SBLU's Wang He and Michael, we would like to thank you for the outstanding presentation. Very good material. I like it so much. And,
thank you.
Of course, we are open to the audience. We're open to questions. Please feel free to make you know, any questions you may like.
And only to remember, if you want to, if you have any questions and have any difficulty in English, you can ask in Portuguese, and Vicente and me will translate it to Henri and Michael. Be free to make your questions. Cada de vocês presentes, caso tenham questões e alguma dificuldade com relação ao inglês, pode fazer a pergunta em português mesmo, porque nós daremos um jeito de passar isso para o Henri e para o Michael, ok? Fiquem à vontade. Alguém quer se manifestar? No?
Okay, so if there's no question, I have one question. Actually, is a comment and a question. I was impressed about the fact that if you have a window, you feel cooler, right? This is good because in the 80s, I was able to spend some time working in the Silicon Valley, the San Francisco Bay Area. And in the company I was working, all the high management, they used to have window booths, right? All the others, they have central booths in the office, right? So yeah, window view is really a nice thing because, you know, all the high management, they have the right to have a window booth. So that's only one comment. And I have a question. As you may know, several companies today, lighting fixture companies, they are providing a kind of ceiling fixture mimicking the sky with, you know, the blue sky and the clouds. So this is something quite new. But in terms of window, do you believe that we can have a very view quality index using displays instead of real windows?
I think that's a good question. And then there are some researchers try to like compare if the display can be replaced by, I mean, windows can be replaced by displays, but I didn't find any conclusive results. So that could be like a future studies, I think.
Yeah, because I was involved in a project here in the city of Rio de Janeiro, in an office which is totally underground. There's no one single sun lumen coming from the sun, right?
Yeah.
And it's very difficult to light the, you know, such environment because as as you guys just show us, window view is very important. It doesn't matter, right? Okay, there's a preference, but our windows is always good. But in a basement where there's no possibility to have a window, I was thinking about, something related to displays in order to mimic a real window. So maybe it's something that we should study down here. I think that, could have some benefit.
Right.
I think so too. I mean, I'm not quite sure what the comparison between an artificial window with a view is and an actual real window with the same view, obviously being compared across, kind of both kind of display kind of mediums. I would assume that having artificial window with a view is still better than having no view at all. That's for sure. But I was approached by this a few times recently with people asking whether or not they're comparable, the two. But I feel like at the moment, even with the technology we have to implement an artificial window, there are still things I feel like in a real window which we can't necessarily replicate in that level of detail, which I feel like occupants, if they're looking at an artificial window, can tell that this is not a real window. But I still feel that there probably is some beneficial kind of things we can do just by implementing it, particularly in spaces where we can't put windows. So this is also something here that's also in Singapore of an interest, because land availability there's not a lot of land availability because Singapore is quite small. So there's a lot of high-rise buildings, but then obviously if you can't build up, you build down, and that's where what's happening is a lot of underground shopping malls and places like that. And yeah, there's a lot of scope to implement these types of technologies and of for sure interest. So, but yeah, as a comparison between the two at the moment, yeah, I feel like just speaking off the top of my head, like out loud, I feel like there is probably a difference.
Okay, thank you.
Okay, and Vicente, we are now starting our research with Christiane, that is not here at this time, and she is studying this kind of display that is called the virtual light systems. And our intention is to verify if when a people in a person in a room without a natural window, but only a virtual light systems. But if this person don't know if that is a virtual window, we are trying to understand, to investigate if, in this case, the balance among cortisol and melatonin has an improvement when the person don't know if he or she is in a room without a real window. I don't know if this is real, but we are investigating about that.
Okay, good.
That's a really interesting research question, yeah, for sure.
I hope we have many to talk, Michael and Wendy, about these results.
I think it would be beneficial, right? Yeah, because it's the light spectrum, right? So like if you can tune the artificial source to daylight and
over the course of the time, right? In the morning
like,
to the
like blue enriched in the morning, and then you just deplete it as the day goes on. You should have an effect.
And you have here a question made by Andrea. She wants to know this question is addressed to Henri and Michael. What do you think about a place indoor, like a garden indoor? Maybe it could be a possibility if I do not have a view. All right.
Yeah, it's more like indoor garden, right? Like courtyard.
A biophilic. I think she's referring to biophilic room, I guess.
Mm-hmm.
I think that's a great question. I mean, something I neglected to mention in my presentation was that I think design, out of the 3 design elements that we've raised with one of his presentation too, view, content, access, and clarity, probably content is the most difficult to design for, because when you're given a site and that's your view of the surroundings, you know, there's not really a lot of flexibility you can do in terms of if the view outside is not particularly great. So because that's what you inherit. And even if you have good, for example, site orientation and massing, for example, it doesn't necessarily get around those problems. And it's probably a caveat of designing for content would be that. So as an alternative, what we did propose in our framework is that if the outdoor content is not great, so for example, there is not a lot of nature outdoors in the view anyway. So like, for example, like you could be in a very dense urban city center, then what you could potentially do is look at integrating those features within the architecture itself. So for example, like one he already mentioned, like a courtyard, indoor garden would be another alternative, biophilic features, for example. I mean, these could help kind of alleviate problems of designing for view content when the window view itself doesn't have great content. So there adds that little bit more flexibility in terms of, for example, like in a worst case scenario, you can still do this, and this may lead to a positive effect. So for sure.
Yeah, and then that's also partially reflected in the some of the green certification systems. So I think Singapore's green certification already have some credits if they include some indoor courtyard or like green facades to mitigate that effect. So, but it's not, how can I say, universal throughout the old standard, but I think we see more and more biophilic design aspect included in the building standard or green certification system. Yeah. Oh,
Okay. Any other question?
Any other question? No. So, in name of Esbeluz and in name of my students, my graduate students, I thank you, Henri and Michael, for this presentation, for this beautiful presentation. I learned a lot with you both today. Thank you very much.
Thank you so much for inviting us.
It was a really nice opportunity. Thank you very much. We appreciate it.
Okay. Bye-bye.
Okay.
I see you. Bye-bye.
Bye.
So bye, guys. Thank you.
Bye-bye.
Bye. Ciao.
Ciao.